Hello everyone, I'm Neta. I'm the Scientific Director of Prize4life, and I wanted to talk to you today a little bit about our mission and how it relates to this conference. So, Prize4life mission is to accelerate the discovery of treatments and a cure for ALS, using powerful incentive to attract new people and drive innovation. So, I'm going to walk you through this mission and what it takes to achieve it. But the first and most important thing about it is our motto, the next ALS breakthrough can be yours, and that applies to each and every one of the labs here in this room. Really, this is the core message of this meeting, that we want you all to work on your breakthrough and see how you can help each other and collaborate with each other toward this goal. Myself and Prize4life, and I speak also on behalf of our co-CEOs, Shari Shoni, which you'll hear soon, and Avichai Kramer, who you've heard about before and sends his regards. We all are very committed to having a breakthrough in ALS, and even more so in Israel. And we will help you in any way we can to reach this goal. So a little bit about us. The reason that we are so committed to promoting a breakthrough in ALS research is because we don't have a choice. Prize4life was started by Avichai Kramer, who was diagnosed with ALS when he was 29 and an MBA student at Harvard. And what Avichai decided to do when he discovered he has ALS was to use all of his skills and connection and expertise from Harvard and from before and do everything he can to put them into use for an ALS breakthrough and eventually treatments and a cure. But the question is, what can one person do to make a big change in a complex field like ALS research? And the answer is, in short, to bring people together, to bring people to ALS research, to bring people to work together among each other. And this is what this meeting is about. So I want you to understand how vital your work is for our mission. Now, I'm going to walk through some of the changes in ALS research and how they relate to what we do. So generally, as Danny said, we've seen a tremendous growth in ALS research in the last several years, maybe a decade or two. So the discovery of SOD1, which was the first ALS gene to be discovered, was 20 years ago in 1993. And you see that before that there were almost no publications regarding ALS. And slowly there was a growth, there was a development of the SOD1 mouse model that most of you know. You might not be perfectly happy with it, but it's much more than other diseases have that don't have any mouse model to work with. And then we see a tremendous growth in the last, let's say, 7 to 8 years, with a lot more publication, a lot of genes discovered, a lot more venues of research. And just to elaborate a little bit of what we found just in the last less than a decade. So in this time, since all the ALS research people in Israel could be put in a phone booth together, like Danny said, until now, so we saw a lot of growth in the understanding of disease mechanism. So this graph shows genes, but I want to talk a little bit about function. So we saw that the SOD1 gene that was discovered but not as understood in the last less than a decade, we've seen a huge growth in the understanding of what it does. It's found in aggregates in the cell. These aggregates are toxic. They attack other proteins. They attack organelles like mitochondria. You also see them in mitochondria, only in diseased tissue, not in normal tissue, suggesting that maybe mitochondria and energy balance are also involved in ALS. You also see them in astrocytes, and you see that astrocytes with SOD1 aggregates are toxic to normal motor neurons, suggesting also that glial cells are also important to ALS. Then in 2009, we saw also the involvement of FOS and TDP43, so a new entering into the field of the importance of RNA metabolism and splicing. Another breakthrough to that was the understanding that aggregates with FOS and TDP43 are found also in patients that don't have any mutation, suggesting a connection between familial ALS and sporadic ALS that wasn't previously understood. Also, we found these aggregates in other diseases like Alzheimer and Parkinson, again suggesting shared mechanism between different neurodegenerative diseases. And the last important gene to mention is C9orf, so chromosome 9 open reading frame 72. C9orf is important because it's by far the most popular mutation to be identified, and it's even found in a lot of patient groups before considered to be sporadic, and because it tells you something about the relationship to other mechanisms such as cognition that were not previously associated with ALS. So we see generally a tremendous growth in ALS research, and we also see that the ways to go about in developing treatments for ALS grew substantially. So if I talked about SOD1 aggregates, you can look at how to reduce the aggregation or promote the degradation of these aggregates, but it's not limited to that. You can also look at ways to look at regeneration by either stem cells or stem cells that secrete neurotrophic factors. You can look at neuroinflammation that we now know is involved heavily in ALS. And if you look at the drug market for development of ALS therapies, you see a tremendous growth in recent years, with many companies targeting ALS. Currently, more companies have ALS drugs in the pipeline than companies have Alzheimer's drugs in the pipeline, because there's a vast number of potential targets. So you can look at drugs that affect protein misfolding and protein accumulation. You could look at drugs that affect mitochondrial dysfunction. The most famous example of which is the Dex drug that was developed by Biogen and sadly recently failed, a large phase 3 clinical trial. You can also look at neuroinflammation, at glutamate excitotoxicity, and again you can look at delivering medicine outside the cell, for example, through neurotrophic factors or through injection of stem cells, either for delivery of neurotrophic factor or to replace the mononeurons that have died. And you even see the development of treatment for muscle physiology to compensate for the deficits associated with motor neuron loss. So the field of ALS research is growing substantially. However, what we see is that there is a tremendous gap between the academic research that is already peaking now as we speak and can grow much more, to what eventually reaches the industry and gets tested. So there is a gap in time between between academic research and industry research. This gap in time, looking at it from a patient perspective, is devastating. A lot of the most promising technologies reach clinical development or end clinical development over 10 years after they were found in the clinic. So for most ALS patients, it's twice or 3 times the amount of time that they have to live. Also, we see that many times the most promising technologies found in labs never reach clinical development by industry because there's what is known as the valley of death between academic research and industry research, meaning that as promising as the academic research is, its industry is more and more reluctant to pick up drugs before they were tested clinically. So this leaves a gap of very promising technologies that don't get tested and don't lead to treatments and a cure. And within this range here is our work at Prize4life. We want to make sure that all of these different parts are fulfilled such that there is promising basic research, and it does get translated into industry and later into the clinic as efficiently and as fast as possible, because ALS patients cannot afford neither the inefficiency nor the wait. So how do we go about doing this in Prize4life? Our mechanism as an organization is that we try to identify the most, the biggest hurdles in developing ALS drugs. And the biggest hurdles I think all of you here are very keenly aware of is the need for a good scientific rationale, so a better understanding of disease mechanism and a better understanding of how to target these disease mechanisms effectively. But there are also other hurdles. For example, better animal models to test potential treatments on them, and then also better biomarker to allow better clinical trials such that this potential therapeutic will actually reach the clinic. In Prize4life, we want to approach all of these problems. And what we do with each and every one of these problems is that we identify the problem, we define what is needed to solve it, and we develop a challenge around that. So we have prize programs around each one of these burning needs in ALS. And the reason we develop a challenge is to build a community around that. When you put a challenge to the community, for example, $1 million prize for developing therapeutics that can increase survival by 25%, that we'll talk about later, you see that people have the opportunity to rise to the occasion, to help them work on this challenge, and we also give them regular ALS news and help them collaborate with each other. And this brings me back to my final point, which is that the most important thing about this talk and about this day is the work that you're doing in the lab. And can you bring this meeting and this sense of the community we have in the room here right now into your labs, continue to work together, and remember, in every given time, that the next ALS breakthrough can and will be yours. Thank you for your work, and thank you for this time.